Ladies and gentlemen, this is Freddy Madonsela and welcome back to my YouTube channel. In today's video, we'll be looking at quadratic function, or rather a parabola function. So now when we speak of something that is quadratic, we speak of something that has the highest power of 2. So now let's look at the general formula of this function. The general formula of this function is y equals to ax squared plus bx plus c, or you can also write it as y is equals to ax plus p all in squared plus q. But now let's focus on the one that is common. First, let's break this formula by discussing properties. Saying we are looking at the properties of this function. So now, if you speak of properties, so that means the first thing that you need to look at is the shape. So in our formula, A represents a shape. So now, our shape can either be greater than 0 or less than 0. So therefore, let's say we are having A is greater than 0. So if we are having A is greater than 0, then our function will have a certain shape. So now, saying that A is greater than 0, so that means our function will look like this. So if it looks like this, we usually say it has a smiley face. And if A is less than 0, then we tend to say the shape of our function will look like this. And we usually say it's a sad face. But it makes sense. Let's say that you receive an amount of 250 from your parents. So when you receive this amount of money, you become what? You become happy. You'll have the smiley face because you'll be spending that money buying sweets or anything that you want. But now, saying that your parents gave you that 250, then you lost it. So if you lose it, then you are having a negative 250. So if you lost money, will you be happy? No. You'll be what? You'll be sad. So that's why we are saying if A is less than 0, then we are having a sad face. But if A is greater than 0, then we are having a smiley face. So now, let's look at the other property. Saying that now, we are looking at the axis of symmetry. Axis of symmetry. So now, our axis of symmetry is x is equals to a negative b over 2a. So that negative b comes from our general formula. So therefore, what is our axis of symmetry? We just discussed the shape of our function. Let's say now I'm having a function like this. I'm having a function like this. So now you see, okay, I'm having a smiley face. But now, since our function, it has a curve somewhere here. So that curve, we call it a turning point. But we'll be discussing that after. So now, axis of symmetry is the line that cuts your your function into two equal parts vertically. So therefore, this line here, the one that I'm drawing now, we call it an axis of symmetry. Because if you have, saying that you're having, let's say this is your Cartesian plane. We know that this is our y and this is our x. So now our axis of symmetry here, if you check, our axis of symmetry here, it goes here and it cuts what? Our x axis. So if it cuts our x axis, so that means here we are having an x coordinate which is equals to a negative b over 2a. So that x-axis coordinate, we call it what? Our axis of symmetry. So now let's go to our turning point. So since our graph has a turning point, is turning at this point, we already know that the turning point coordinate x is our axis of symmetry. But what is y? Remember, a coordinate is made up of x and y. So therefore, we know that the x-intercept or the x coordinate of our turning point is x equals to a negative b over 2a. Then, so that means to find our y, we need to substitute our x value that you find, which is our axis of symmetry, into our general formula. So that means our y is equals to f, a bracket, a negative b to a. So therefore, in general, that means our turning point is equals to the coordinates a negative b 2a is to y when you substitute your x. So it will be a negative b 2a. So this is your x is to y. So now let's look at restrictions. So now, if you are having a function, your function can be, let's say I'm drawing my function here. So saying this is my Cartesian plane, and now I'm having a function. My function can come from this direction and go to that direction. But now my function has restrictions. For example, if you check here, we said this is our turning point. So if it's our turning point, you see that our graph, it comes from infinity, a negative infinity, and goes to infinity, a positive infinity. But it doesn't touch our x-axis. So that means we are having a what? A restriction. So that's where we have what we call a domain and a range. So a domain is a restriction that we check when we are checking the restriction in terms of x. So now we say that our domain is x, the element of all real numbers, and the domain, the range, is the restriction of y. So therefore, our y will say the range of y, which is our range, it will be y is equals to or greater than f at negative b over 2a. We said this is the y coordinate of our turning point. So if you go here, you see that at our turning point, our graph that it only is equal to, let's say here it was -1. So that means our graph is 1, I mean. So that means our graph was going to be 1. So our restriction was going to be 1. But in terms of x, we're going to have infinity because of our graph doesn't have any restrictions. So therefore, the range could be y is equals to or greater than f at negative b over 2a, or we'll say y is equals to or less than f at negative b over 2a. Remember, this is the y coordinate of our turning point. So now let's look at the important factor on how to sketch a graph. So to sketch a parabolic function, we'll say to sketch a graph we need certain things. For example, to sketch our graph, we need to find x and y intercepts. We also need to look for our axis of symmetry, which they will also help us to look for a turning point. So therefore, we'll also discuss on how to draw a graph. Let's first focus on properties. So then we have other properties that if you want to find the equation, let's say they say determine an equation. How do you find an equation of a graph? First, you need to look. Let's say you are given, if you are given x intercepts and a point, you need to use the formula that says y is equals to a open bracket x minus x1 a bracket x minus x2. So this formula will help you to find your equation. So if you are not given x-intercepts and 1 point, but let's say now if given 3 points, any points on the graph, then they say find the equation. So to find the equation, you use the formula that says y is equals to ax squared plus bx plus c. So therefore, you need to find your a and you need to find your b. So, but because of you have 2 unknown variables and 3 points, so that means you need to solve using this. You need to solve this simultaneously. So then sometimes you'll find that you'll be given a turning point. Sometimes you'll find that they want you to find the equation, but now you're given a turning point and 1 point. So what you need to do, you need to use this formula. Y is equals to a open bracket x plus p all in squared plus q. So therefore, we know that if you are having this formula, we know that our turning point coordinates will be a negative p is to q. So what I'm trying to tell you is that if you are having your general formula in this form, then your p and your q are your turning points. So now we also have natural roots. Natural roots. So if you are having real roots, then know that your function should be greater than 0. And if you are having equal roots, your function should be equals to 0. And if you are having non-real roots, then your function should be less than 0. So these are the properties for a parabolic function. On my next video, we'll be solving questions. I thank you.